together. So, anyways, so this is actually the sine rule. So trig 11 was about the cosine rule. This is the sine rule. Okay, this is another nice rule that allows us to solve triangles. Okay, so it's one of those rules you're going to want to write down somewhere. Okay, because we're going to use it over and over and over again. So, especially today. Now, some of your homework, and I don't have any examples like this, may actually use both rules, but for the most part, just assume that it's using the sine rule. So we're going to start with a triangle, all right? And we have A, B, and C. So I have A is 105 degrees, B is 27 degrees, okay, and little b is 10. So I'm missing all these other pieces. I'm missing this one, and that one. Okay, when you solve a triangle, you have to find all the pieces. So I'm going to use the sine rule because it's very, very easy to use. I'm going to start with finding little a, okay, which is across from 105. So I'm going to do, sine rule says, okay, 10 over, so b, over sine of b equals a over sine of a. Okay. So these are all proportions, and they're all equal. So a is equal to b, b is equal to c, a is equal to c. So now I can solve this for a. So I end up with 10 sine 105 divided by, sine b, sorry, I should have written this in, that was 27, divided by sine 27. And all I did was multiply both sides by sine of 105. Calculator, put that all in my calculator, and I end up with a equals 21.3. Okay, that's the first one. So I have this one here. I have 21.3. Okay, now I need to find both C and little b. I'm going to actually go with, doesn't really matter. I have B. Why do I have that circle? That was, I have B. No, this is C. So I have A. I wrote it all in the wrong spot. I'm sorry, I should have put my letters on there. Okay, so we know this one. I just found A, which is across from 105. This is 21.3. Okay, now I find C and little c. So to do this one, the first thing I'm going to do is I'm going to go 180 minus 105 minus 27. Okay, and that's going to give me my angle. All right, always use the easy way out if you can. Okay, so my angle for C is 48. All right, so now I have my angle, and now I can use my triangle. So C over sine of 48 equals 10 over the sine of 27. Also, okay, you could use 21.3 over the sine of 105. It will work exactly the same. Okay, the answer will be exactly the same, but I just like this one better. So I end up with C equals 10 sine 48 over sine 27. I use my calculator, and I end up with, where's my answer? 16.4. So this one right here is 16.4. So that's fairly straightforward and fairly easy to use. Unfortunately, it doesn't stay that easy. We are getting a little more complicated. So, all right. So we want to note that, now this is just notes, I pull them out of your book because you want to make sure I talk about it, that if you have from geometry, you have the 4 triangle congruence theorems. Angle, angle, side, side, angle, side, 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 and angle, side, angle. Okay? So that they always talk about that a unique triangle can be formed that is congruent to a given triangle. However, okay, if you have side, side, angle, there is no proof for that. Okay, and it's not congruence theorem because it doesn't work. All right. So you could, if you have a side, side, and an angle, you could have no triangles. You could have 1 triangle, or you could have 2. Now we're always going to assume 2. Okay, we're always going to assume 2. And so how this works is it's saying, if 0 is between, if theta is between 0 and 90, the sine of theta is also the same thing as the sine of 180 minus theta. This is a rule that we have that we learned before. So what that means is that any of my angles that I find, I can actually subtract from 180 and try the other one. So we're always going to assume 2, and then I'll talk right at the end about what happens if, how you can know if it's just 1 or if it's 2 or if it's 0. But we're always going to assume 2. So you end up doing most of these problems twice if you have side, side, angle. So This is another, the graphic didn't show very well. Kind of talks about why it happens, okay? So in one side, the A is the side, you notice this A is too short. It's not going to fit, okay? So this is if no triangle is formed. The way that this will happen is you'll end up with your sine rule. You'll have the sine of something or the cosine of something. It may be the cosine rule that you're using, and it will give you an error message on your calculator. It means it cannot be calculated. That's typically what happens when you have none. Okay, this is one when there's only one. Okay, it ends up in a 90-degree angle. This is usually a very nice situation. So here's a couple of other situations where you could have one or two. And this is one where you have two. So this triangle right here is one triangle, and then this triangle right here is another triangle that's formed with the same side angle. So with this is where we'll have two answers. So we end up using those sometimes. Now this is the one where you have just one, okay? Usually what happens where you only have one is you'll use two of them, but then when you add up the three angles, it doesn't add up to 180. So there is no, so there's only one answer in that situation. Only one adds up to 180. So it's either too big or you'll end up with, it's usually too big. So, all right. So another couple of rules that we can use, okay, if we're looking for the area of a triangle, we can use the 1/2 AB times the sine of C, okay, which that's not used very often. This is actually the really nice one where it says the area of a triangle with sides A, B, and C, okay, all you need are the sides, you can find the area, is the square root of the side S times S minus A, S minus B, S minus C, where S is 1/2 of A plus B plus C. So we're going to use this rule right now, and then we'll go and do our sine rule again. All right, so we have three sides of a Broadband area. Make sure you read your directions on your homework. They're going to tell you to do different things. So I actually don't even want to draw a picture. Okay. So for this example, the area that I'm looking for, we're going to first define S, which is 1/2 times 4 plus 12 plus 14, okay? And that equals approximately 22.2. That's our answer. Okay, this is 15. Okay, so S is 15. Then I can do my square root of 15 times 15 minus 4 times 15 minus 12 times 15 minus 14. Okay, so I do the square root of that. I mean, honestly, this is on calculators. That's so simple. And I end up with approximately 22.2. So just use a formula. Make sure that when you're looking for area that you know what formula you're looking for. You may have to use other rules to get all three sides. If you don't have all three sides, and all you have is a couple of angles or something like that. So, okay, last example, and this unfortunately is the longest one. All right, I'm going to give, I have this triangle, and B is 12.5, C is 20.1, and capital B, or the angle, is 37.3. So this is one where I have to test and see. I have to actually solve it twice to make sure that I have taken care of all of my stuff. So here is, here's my triangle. It actually is, it could be two triangles. So I have A, B, C. This is 12.5. This angle here is 37.3, and C is 20.1. So you notice there's side angle. Okay. So when we end up in this situation, so we have to be really, really careful about how we solve it. So the very first thing we're going to do is we're going to find an angle. Right? It doesn't matter which one I find, whether it's A or C. I'm going to go ahead and, yeah, it does. The only one I can find is C. A is too hard because I have both of them missing. So I'm going to find C. So I use 12.5 over sine of 37.3 equals 20.1 over the sine of C. Okay. So through some manipulation, okay, I'm not going to do this all on the board. You should be able to handle this. Okay, these are proportions. I end up with sine of C equals sine 37.3 times 20.1 divided by 12.5. Okay, if I put that in the calculator, I end up with sine inverse 0.974, which equals 77. So my angle C here is 77. So I need to check both angles here. So now, talk about the idea that the sine of theta is the same thing as the sine of 180 minus theta. So we're going to go 180 minus 77 is 103. So we're going to test both triangles with C being 77 and with C also being 103. So let's go ahead and we're going to put both cases out. I need to erase this side so that I can. Now I'm going to write this out kind of nice. We're going to say case A. And this is how they're labeled. Right? So I have A and little a. Okay, don't have those pieces yet. B is 37.3. Little b is 12.5. C, now I'm going to use one of my C's. I'm going to use 77. And little c is 20.1. So both of these cases are. In this case, we're going to have to find big A and little a. All right, now case B. Okay, again, A and little a, right? And I'm going to go B, 37.3, 12.5. Okay, now we're going to do C is 103, C 20.1. Now, finding the angle is easy, 180 minus those two added together. So in this case, A is 65.7, and in this case, A is 39.7. Okay, let's stop and talk for a moment about how I would know, is it 2 or not? Okay, at this point, they both work out to nice 180-degree triangles. If it were, if they were not, this would be a negative number. You can't have a negative side, okay? Or it would be a number, yeah, you do 180 minus that, it would be a negative number, which means that then it would not work. There would only be one that would work. I'm not actually going to go through the work for A on this. It's the sign rule again. Okay, you know how to do that by now. I would hope we did that in a couple of other examples. So the only other thing I want to talk about is if, how do you know if it's no solution, like the side's too small? What will happen is you'll do a cosine of something, right? You'll do an inverse of something, okay? And you'll end up with an error, okay? Then it will be no solution. So now if you want to work this problem out on your own, I will put the answer up here, okay? Little a for this one is 18.8, and little a for this one is 13.5.